Okay, let's have a look at ERC3643, a very popular Ethereum standard, also called T-Rex protocol. This standard is used for real-world asset tokenization. As you can see, this is the main website, ERC3643.org. And when you open the white paper, there are a few things to notice. There's a very comprehensive description about how the token works. There's also a bit more information around the functions used in the token and how it utilizes the on-chain ID function, which is basically using ERC734 and 735, linking the investor identity as well as the agent identity with blockchain. It can also cater different compliance modules like KYC, AML checks, or country or region, or maximum number of tokens in a wallet, things like that. There's also a GitHub repository for ERC3643, and as you can see that all the contracts as per this standard are already saved in the repository. It's open source and anyone can clone the repository and use them. So I'm now testing the ERC3643 using scaffold ETH. So the first step is to start hard hat, and then we will deploy our contracts. And then we are gonna run in a separate terminal. We are gonna run the app as our front end. As you can see, all our contracts are deployed. Now we'll start next app. Clicking on the link, there's our front end where we can interact with our contracts now. Now working in our front-end environment, we have a home page, then we have a contracts page, and we can see that all the contracts from ERC3643 which we have deployed are showing up here. So the first thing would be for us to connect a wallet. With Scaffold ETH, we have got a few options there. There's a built-in burner wallet which we can activate and get some ETH from the faucet, or we can also connect the MetaMask wallet. For this case, we are going to connect the wallets from our local host from Hardhat, and I'm importing the Hardhat accounts here. So we'll need 4 accounts basically. The first one would be the main admin account, that will be Hardhat 0, and then I'm going to import the rest of the accounts. The second account would be for the claim issuer, and the third and fourth accounts will be dummy user accounts. We'll connect these accounts with the chain, the local network. And as you can see that our web page is showing the connected address, which is the first Hardhat account. The next step is initializing the main contracts, which include the claim issuer registry, the trusted issuers registry, and the identity registry contracts. The contracts were deployed by default with a 0 address. Once we initialize these contracts, we can see that under each contract the owner will be changed, and we can also see that transaction going through in the block explorer. Now we need to initialize the identity registry and connect the identity registry with the identity storage, claims topic registry, and the trusted issues registry contract. So as you can see that we have connected the 3 contracts together, and you can see all those contracts on the left hand side, with the wallet Hardhat 0 wallet being the owner of that contract for now. The next step is to initialize the token contract. Let's give a dummy token name and a symbol, and connect it with the identity registry and the compliance contracts. As the transaction is completed, the token is now on chain, ready to be minted. The next step is to add a claim topic and issue a claim topic for our claim issuer to submit. In this case, we are just entering number 7, which represents KYC and AML check for our claim issuer. Now we can see that the claim topic is showing up on the left hand side. Once we issue the claim topic, then the claim issuer have to confirm their identity and complete the KYC checks. For the purpose of claim issuer identity contract, we are just transferring the ownership of this contract to the claim issuer, which is the second address number 1 from hardhead, which represents the claim issuer, and we can see that the owner is now changed. The claim issuer have to complete his identity check, and we can just check that currently there's no identity contract link with that user address. There are internal functions under identity registry contracts which carries out on-chain ID test, where the claim issuer have to assign a signer key to confirm his identity. As we can see that the function gives an error saying that there is no agent assigned, or the function was not called by the agent. The way these smart contracts are set up is that there's another function, another role, which is for the agent who manages the claim issuer's registry. Once the claim issuer identity is verified, the main account or the admin account needs to add this claim issuer into the trusted issuers registry contract. We can check that currently this user or this claim issuer is not added to the registry from the read function, and now we can add him and add trusted issuer function. Now we can check whether this claim issuer is trusted or not, and as you can see that the read function is showing that it's now added. The next step is to add the two users, account number 2 and account number 3, and add them to the identity registry storage. First, we have to initialize the identity registry storage smart contract using the admin account. Now we will add the identities to the storage registry. The users need to complete their own identity registry contracts similar to the claim issuer with a claim issuer topic, for example KYC and AML, and once they complete that function, their identities with their address and the identity contract can be added to the identity registry storage contract. We have now added the first user, which is basically the hard hat 2 account, and we can check that the identity is now stored with their identity registry contract. The next step is to add or mint tokens to the user or investor. We will use the mint function to mint 1000 tokens to the user. Since the identity of the user 1 is already registered and it's on chain, the mint function went through and 1000 tokens are minted to user 1. We can check the total supply of the tokens on the left side. Now we are checking the wallet for the user 1 to see if the tokens are added to their wallet. As we can see, 0.00001 NTN have been added to their wallet. The reason being that we have defined in the token properties, we have defined 8 decimal places. That's why adding 1000 is adding 0.00001 NTN in the user. Just to check, we are increasing the zeros in the amount of tokens and minting it again. The transaction is successful, and now we will check the wallet. As we can see now, the wallet is showing the exact amount of tokens. We can also check the total supply. Using the similar procedure, we can also register user number 2, and we can also mint tokens to the user number 2. At the moment, when we try to transfer half of the tokens from user 1 to user 2, we can see that there is an error. Even when we unpause the tokens, it says that the transfer is not possible. This is because we haven't completed the identity registry for user number 2. This shows that the on-chain ID function is still working,